limit of sequence. When you take calculus, your best friend will be named limit because you will see the limit all the time. So get, close with limits now. So what is limit? We already learned how to find the limit and how to write it in a notation. So it's LIM. How do you read this? Isn't this limit as n approaches positive infinity? What does AN become, right? So if you're looking for the farthest term that we can find, if the limit is finite number, like if it approaches 0 or 1, like horizontal asymptote, we can also call it n behavior. The sequence converges to that number, and that's a limit. And the limit is infinite, meaning what? If it goes to positive infinity or negative infinity, then it does not exist, and we can say it diverges. So let me give you a few examples. So when you look at the arithmetic sequence, when you're always adding or subtracting a difference, it will either always increasing or decreasing. So would it diverge or converge? Diverge. Arithmetic always, arithmetic sequence always diverges. Okay? What about exponential? What about geometric sequence? So for this case, let's say we are multiplying by 2 each time. Would it diverge or converge? It will diverge. What if it's -2? Let's say you're multiplying by -2 each time. What happens? You can start from 1, and then you get -2. When you multiply by -2 again, it becomes 4, positive. Then it becomes negative, positive, negative. Would this converge or diverge? It diverges. But what about this case? For geometric sequence, what if it gets decay like that? Would this converge to, it will converge to 0. So when would it converge? When the ratio is, between, can be negative. Remember, negative, it alternates. And if it's greater than 1, then it gets bigger and bigger. So if the ratio is between 0 to 1, like 1/2, 1/3, that's the only case that it will converge. Otherwise, it will diverge. Okay? Let's go ahead and look at this example. Does it have any pattern? It's 2 to 1. It's not arithmetic. It's not subtracting by 1 each time. It's not dividing by 2 each time, so it's neither arithmetic or geometric. But what do you notice? It's 2, 1. What's 2/3? Isn't it 0.67? 1/2, 0.5. 2/5, 0.4. So what do you notice? Doesn't it get small and small? Would it ever become negative when n gets bigger? No. So that means what? It will have a limit as x approaches to, or n approaches to, positive infinity. We can call it AN equals to what? 0. It gets closer and closer to 0. So it means it converges. If you have, this is not arithmetic, but if you have one like this, that converges, right? So 10n minus 10, what type is it? Isn't it arithmetic? It is increasing by 10 each time. That's a common difference, right? So it will always increase, so it diverges. What about 5 to the n? It is geometric. And what's the rate? Equals to 5, which is greater than 1, so it diverges, right? It will look something like this. It will go exponentially grow. What about here? Why is it diverging? It is arithmetic. So all arithmetic sequence diverges. What about the third one? What kind is this? What are we multiplying each time? 5, 1/5. 1/5, 1/5, so it is geometric. What is the ratio? 1/5, is that between 0 to 1? Yes, then it gets smaller and smaller as you can see. What's 1/3? 125. It's like 0.0001. It gets closer and closer to 0, but never becomes negative. So it will look something like this. Okay? So this is converging to what? 0. Limit is 0. What about 5/6? What's 1? Isn't it 6/6? What's 4/3? Isn't it 8/6? So the numerator is getting bigger by 1 each time. So this is 9/6. So what does that mean? It diverges. It's increasing. Is this arithmetic or geometric? No. Neither. You're number 3 in line. What about 0.1? Isn't this? You have to wait. There are 2 people ahead of you. You will see when I'm done. They're going to leave right after I'm done. So what is 0.1 to the n? Isn't that 1/10 to the n power? So what is this? Isn't it geometric? What is the rate? What's the ratio? 1/10, which is between 0 to 1. So it converges to 0. It gets 1/10, then 1/100, 1/1000. It gets smaller and smaller and approaches 0. What about this one right here? This one, you approach this question same as the horizontal asymptote. How do you find the horizontal asymptote? You have to look at the leading terms, right? Why? If you have infinity, like a 10,000, would -2 really affect the number? Would +4 really affect the number? No, so you have to just look at the leading term, which is 10n over -5n. And if the top has a greater degree, remember, it goes to infinity. If the denominator had a greater degree, remember the pyramid, if the bottom has a greater degree, it goes to 0. If they have a same degree, then you just got to look at the ratio. What's 10 over -5? -2. It converges to 2. Limit is 2. So how would you write it? The limit as n approaches positive infinity of that sequence was it -5n equals to 2. Okay. So go